Hello, welcome to my Intro to Fractions video. So here's a brief review of what we went over before. Rational numbers, what this chapter is about, and rational numbers is another phrase for fractions. So what is a fraction? We talked about that. The main thing people think about as far as fractions go is it's part of a whole. So if I had a whole cake here and it was broken into 1, 2, 3 equal pieces, and I am interested in those two right here, this fraction represents 2/3 of the whole. So here's my 2 pieces out of 3 in the whole. Part of a group is similar, where we have 3 objects and 2 of them are of significance for some reason, and so this again would represent 2/3 as a fraction. And it's debatable whether these two are different representations of what a fraction is or if they're the same. This one is mathematically the idea of continuous region. Here I have discrete objects. So a couple of different ideas there, but they're kind of the same in terms of their concrete part, although we do have continuous versus discrete, connected versus disconnected. Fractions also represent a division problem, where if I wanted to talk about 2/3, I have 2 objects that need to be broken into 3 equal pieces. Oops, it's supposed to be an E. Okay. And so then I have to make my cuts. 2 cuts break stuff into 3 pieces here. And if you imagine putting lines here and here, this section is 2/3, that part is 2/3, and this part is 2/3 of what I started with. So that's a division problem. Notice it's quite a bit different than either of these pictures up here. Then another idea is a ratio, and there's all kinds of different ratios, from speed to cooking to proportions of different things. And so here I drew a picture of ratios of oranges to apples. So in this particular group, there are 2 oranges and 3 apples. And so the ratio of oranges to apples is 2 to 3. Sometimes ratios are written with a colon, so 2 colon 3. You might have seen that notation before. So we have 1, 2, 3. I think those are all different representations physically. And then this 4th one here is a point or distance on a number line or a ruler or something like that. And so from 0 to 1, this point is 2/3 of the way there, and this distance is 2/3 of one whole length in this case. Mathematically, quotient of 2 integers a, b, with b not equal to 0, written with that what we call that fraction bar, which this slash for division is often used, or that division symbol right there. And there's the 4th way if you consider the ratio colon. There are other symbols, but we don't usually use them when we're talking about fractions, but we'll talk about that later. In general, a fraction represents some number of equal parts. And when we write it down mathematically with a numerator and a denominator, the numerator is the number of equal parts, and the denominator is the number of parts in a whole. Numerator, number, answers the question how many, we count. Denominator is what type, it's a description. Denomination, like bills. Okay, so top is how many, bottom tells us what type. And some toys we can use to play with. Zoom out a little here. We got our fraction strip, so I have a strip that represents a whole, another strip that represents half of that. These strips here represent a third. When I put them together, 3 of them make a whole. We've got the Cuisenaire color rods, sorted from 1 through 10 here with the colors. And here I put a green and reds together. And if I take one of these reds out here, you can see that those 2 reds make 2/3 of a whole green. Over here, fraction strips, we can represent 2/3 of a whole there. With our pattern blocks, a group of the blue ones can be used. Two of those can represent 2/3 if the yellow hexagon is to represent a whole. So there's 2/3 there. What representations can you come up with to represent fractions? All kinds of pictures we can draw, toys we can play with. Now, fraction again is a comparison of two numbers using division. It's also a number of equal parts. So we need, with some fractions, to be able to talk about comparisons, how to determine if one is greater or less than another, and that often involves a common denominator. So I'm going to do a few different versions of this. So here I want to represent 3/4 and I want to represent 2/3. So for 3/4 I would have to choose 1, 2, 3 of those pieces to work with. 2/3, similarly, I'll choose a couple of those. And I want to figure out, say, which is the greater one. And the problem is they're just different shaped pieces, so they're not directly comparable. Sometimes we can look and make a guess. The trick is to make them comparable. In this case, I'm going to consider these cakes. I'm going to cut each cake like the other. So the 4th cake I'm going to cut into thirds. So make my best third slice there. And there. Sean, I hope you can see that red. I should use a marker instead, make it more pronounced. So I've cut the quarters into thirds, and then similarly, I'll cut the 3rd cake into quarters to the best of my artistic ability. Okay. So I cut each cake like the other. Now notice the different directions. When I made my quarters cake, I went horizontal slices. When I made my 3rd cake, I went vertical slices. So then it made it easier to cut each cake like the other. And now I have a 3x4 grid representing each one, so I can say, oh well, 3/4 is also 1, 2, 3, 4, 5, 6, 7, 8, 9 out of a 3x4 grid, which should be 12 total pieces. So I can re-describe 3/4 as 9/12, and 2/3 would then be 4, and 4 is 8 12ths. And now that I have compatibly sized pieces, I can say, oh well, 9/12 is more than 8/12. So 9 of a certain shape is more than 8 of a certain shape. So that means 3/4 must be greater than 2/3. Okay. And we had some exercises where we did that with pattern blocks. So let's see if I can do that with pattern blocks here. So in this case, to represent 3/4 and 2/3, I'm going to have to use 2 of these hexagons to be a whole. Then my red trapezoids would represent quarters, and so that would be 3 quarters there. Okay. And then as far as thirds go, the blue pieces represented thirds on a single one, and so if I put 2 of them together, check this out. Oops. Then this shape right here, what's that called, a chevron, I think? 1, 2, 3 chevron shapes make up a whole. So these chunks of blue represent my 2/3. And so it's hard to tell exactly which one is greater looking at these two groups of pieces here, the red group or the green or the blue group. So what I need is some kind of common piece that works for both of them. And the problem is the red and the blue are not directly compatible. They're not off by one of these or the other. So I'd have to reach into my bag of tricks and find something that is. And the green pieces are the ones we'd play with here. Noticing that 2 greens make up a blue, so 4 greens make up one of those chevrons. Oops. I tried making a stand for my camera, but it didn't work very well. I got to get a new one. Okay. And then 3 of them represent a hexagon. No, trapezoid. There we go. Get my pieces straight. So then I just got to figure out how many greens I have in each of these. And I don't. Uh-oh. Thought I had enough. Some are missing. Perhaps they're on the floor. So, just do our best here. So using the green pieces I can see, oops. Bear with me here. Oh, come on. This is ridiculous. Ah! Okay, anyway, there's 8 of them, right? See that? 8 pieces make up the blue. And then over with the red, we would have 3 and 3 and 3, which would be 9. So here we can see of this common denominator, green, we need 9 of them to represent the red area, and we only need 8 to represent the blue. So the red, the 3/4, must be bigger. And so some, not every fraction problem is amenable to using toys. Some are, some aren't. You have to pick carefully. At some point, we need to move beyond toys and get to some kind of algorithmic approach and away from the concrete approach. But kids can play for a long time with these concrete objects and have some fun. So let's try another problem. And we'll do this in different ways. I've got here 3/4. Focus, there you go. 3/4 versus 7/10. So let's color in each of those. So 1, 2, 3/4 versus my 1, 2, 3, 4, 5, 6, 7/10. And so then let's try a different color. We want to cut each of these like the other. And again, here you can see that's going to be a little bit of work, not too much. Let's do the 1/4 one first because it's easier. Quarters you can go half, and then half again. Okay, and then the 10ths, you gotta find some kind of system for drawing your 10ths. So 9 slices will cut something into 10 pieces. And there's my 9th slice there. And so then using some math, I already know this is going to be 10 by 4. So my new chunks are 40ths of a whole. And then as far as the green area goes, this green area is 10 by 3, so there should be 30 pieces there. And this one is 7 by 4, and so there should be 28 pieces there. So here I can see that 3/4 is just a little bit bigger than 7/10. We'll talk about how much bigger then. So it gets the greater than symbol there. Okay. So on paper, this is kind of nice. Oh, this is my math cat. Hello, math cat. How are you today? Oh, just passing through apparently. Bye, math cat. No, I lost my place, math cat. So that's a good place to stop then. Goodbye. Have a good day. We'll be back with addition and subtraction next.